SpaceX fires up Starship upper stage for 9th test flight in static fire trial. What if I told you that tonight, on a quiet stretch of coastline in Texas, the most powerful rocket stage ever built just roared to life? No liftoff, no countdown to orbit, just the deafening blaze of a static fire test, shaking the Earth beneath SpaceX's starbase. And at the center of it all? The Starship upper stage. A gleaming stainless steel beast designed to carry humans and cargo beyond Earth, to the Moon, to Mars, and far beyond. This isn't science fiction anymore. It's happening. And with this 9th test flight just around the corner, we're standing on the edge of a future that SpaceX is forging one fireball at a time. If you've followed the SpaceX journey even a little, you know Starship is more than just another rocket. It's the heart of Elon Musk's vision for multiplanetary life. But Starship isn't a single rocket. It's a system, a two-stage architecture unlike anything else flying today. At the top of that system is the upper stage, also called SHIP, the sleek, fully reusable spacecraft designed for orbital flight, deep space missions, and even interplanetary travel. And in this latest round of testing, SpaceX is putting this upper stage through one of its most critical milestones yet, the static fire trial. So what exactly is a static fire? It's a rocket engine test where the engines are fired at full throttle while the vehicle remains anchored to the pad. No liftoff, no flight, just raw, controlled power. For the Starship upper stage, this test proves whether all systems, from plumbing and pressurization to guidance and ground support, are ready for flight. And when SpaceX performed this latest static fire, it wasn't just a routine test. This was a rehearsal for the real thing, the 9th test flight of the full Starship stack. Over the past few months, SpaceX has refined every detail of its launch prep process. From cryogenic loading rehearsals to pre-flight tank pressurizations, each step has been carefully choreographed. But with this 9th launch attempt, there's a growing sense that something major is about to shift. The upper stage static fire is more than a technical box to check. It's the final green light before the entire Starship system goes airborne once again. Every engine ignition, every second of burn time, brings SpaceX closer to a fully integrated, reusable rocket system. The Starship upper stage is powered by 6 Raptor engines, 3 sea-level optimized, and 3 designed for the vacuum of space. This configuration allows it to operate both in Earth's atmosphere and beyond. But before any mission to orbit or the Moon, SpaceX has to prove this engine array can fire reliably, hold chamber pressure, and shut down cleanly, all without lifting off. That's what makes static fire trials like this one so critical. They're like rehearsals with full pyrotechnics minus the takeoff. And it's not just about fire and smoke. A static fire tells engineers everything they need to know about system health. From thermal loads on the engine bells to how quickly onboard computers respond to sensor inputs, every millisecond is recorded and analyzed. Did the engines ignite within the expected margin? Did they reach the target thrust? Was there any vibration outside the normal envelope? These questions might sound technical, but they're the difference between success and spectacular failure on launch day. When SpaceX rolled out the latest upper stage to the launch site, it was more than just a hardware movement. This was the beginning of launch prep in earnest. Ground crews checked propellant lines, verified hold-down clamps, ran through simulation drills, and prepared for what might be the most ambitious Starship launch yet. And as the vehicle stood tall on the test stand, anticipation built. The roar of Raptors would soon echo across the dunes again. The upper stage itself is a marvel of engineering. At roughly 50 meters tall and made of stainless steel, it resembles something between a retro sci-fi ship and an interplanetary shuttle. Inside, it houses everything from methane and liquid oxygen tanks to avionics, power systems, and payload bays. It's designed to survive re-entry, perform belly flop maneuvers, and land vertically, all autonomously. And when SpaceX talks about taking humans to Mars, this is the part of the rocket they'll be riding in. SpaceX has learned a lot since the first upper stage prototypes took flight. Remember SN8? The first to attempt a high-altitude flight and aerodynamic descent. It didn't stick the landing, but it taught engineers volumes. SN9, SN10, SN15, each test flight pushed the envelope a little further. And now the focus has shifted to orbital tests, where the upper stage rides on top of the Super Heavy booster, separates in space, and re-enters the Earth's atmosphere at near orbital velocity. These are not just flights, they're dress rehearsals for missions to the Moon and Mars. With the 9th full-stack test flight approaching, the pressure is on. Static fire success means SpaceX can move forward with final launch integration. And the world is watching. Every time that upper stage fires up, the footage spreads across social media in seconds. Space fans, engineers, and even rival aerospace firms are glued to SpaceX's every move. Why? Because this isn't just another rocket company. SpaceX is redefining what's possible with hardware, software, and pure vision. The recent test also gave us insight into SpaceX's evolving engine technology. The Raptor engines used in this trial are a new generation, more efficient and robust than earlier versions. Improved turbopumps, simplified plumbing, better chamber stability, all the small things that make a big difference when you're trying to land a rocket on Mars. And with every static fire, those improvements are being validated under real-world stress. This upper stage test is part of a broader Starship campaign, a campaign with ambitious goals and an aggressive timeline. SpaceX isn't just building a rocket. They're building a system that can be mass-produced, rapidly reflown, and scaled up for a global space economy. Think satellite deployments, lunar landings, point-to-point Earth travel, even off-world construction. And at the heart of that vision is a reliable, reusable upper stage that can be launched again and again without missing a beat. The rocket test also demonstrates how far SpaceX has come in terms of operational tempo. Just a few years ago, static fires were days-long affairs requiring endless reviews. Now they're routine. Ground crews can execute a static fire within hours of rollout, analyze the data, and prep for flight with minimal downtime. This operational agility is what sets SpaceX apart from legacy aerospace, and it's a huge reason why they're so far ahead in the game. Another key takeaway from this static fire was system integration. The upper stage isn't just a standalone vehicle. It has to work flawlessly with the booster below, the launch pad systems, the fuel farm, the flight software, and even the recovery ships out at sea. Every subsystem has to speak the same language. A single miscommunication and the entire launch could be scrubbed. That's why static fires are invaluable. They expose any last-minute bugs before they become mission-ending problems. Beyond the technical milestones, this test carried symbolic weight as well. It proved that SpaceX is not slowing down. Despite regulatory hurdles, hardware failures, and the sheer complexity of developing a new launch system, the company continues to push forward with relentless momentum. And this upper stage, the gleaming spearhead of that effort, continues to deliver. Looking ahead, the 9th test flight will be the most ambitious Starship mission yet. The upper stage will ignite, separate from the Super Heavy booster, and perform a controlled descent, maybe even another attempted splashdown. Each part of that sequence represents a new set of challenges. But if this static fire is any indication, SpaceX is more than ready to take them on. And let's not forget the long-term stakes. NASA's Artemis program is counting on Starship to deliver astronauts to the moon's surface. Future missions to Mars depend on this system being not just operational, but dependable, scalable, and safe. Every test, every engine firing, every flame plume brings that future a little closer. And for those watching from the outside, it's a front-row seat to the birth of interplanetary spaceflight. As we wrap our eyes around the footage from this static fire, the white-hot flame columns, the towering shockwaves, the dust clouds rushing outward, we're not just watching another rocket test. We're witnessing history being written one Raptor burn at a time. The SpaceX Starship upper stage isn't just a spacecraft. It's a revolution in steel, fire, and vision. You could almost hear the excitement in the control room, the moment when the engines spooled down cleanly, when telemetry confirmed a nominal run, when the data started pouring in. That's the kind of moment engineers live for. And for SpaceX, it's the final green light on the runway to the stars. In a world full of hesitation, regulatory red tape, and slow-moving bureaucracy, SpaceX has decided to just go for it. To test, to fail, to learn, and to try again, fast. The Starship program, and especially the upper stage, is the embodiment of that philosophy. And it's paying off. So what's next? The flight hardware is ready. The booster and ship are stacking. The range is being cleared. FAA and Coast Guard notices are going out. And sometime soon, maybe sooner than we think, we'll see this same upper stage fully fueled and raring to go lift off atop Super Heavy, break through the clouds and roar toward orbit. Not in simulation. Not in theory. In real life. When it does, remember this moment, the quiet fire trial in the dark, the engine test that said, "We're ready." Because from this point on, the countdown isn't just for a test. It's for a future that's rapidly becoming real. And the Starship upper stage? It's leading the way. To really understand the significance of the recent static fire trial, we need to rewind the clock and look back at where this journey began. The Starship upper stage wasn't always the sleek, stainless steel vehicle we see today. In fact, the very first test articles looked more like giant water towers than spacecraft. Codenamed Starhopper, the earliest prototypes barely resembled anything spacebound. But that's the beauty of SpaceX's approach. Start small, fail fast, learn quickly. Starhopper's short hop tests laid the groundwork for what would eventually evolve into the current Starship upper stage design. The first true high-altitude prototypes, like SN5 and SN6, were simple testbeds with limited control surfaces. They weren't designed to reach space. They were meant to prove that a vehicle could fly, hover, and land using only the raw thrust of a methane-fueled Raptor engine. Those tests were pivotal. They validated the entire design philosophy of the Starship upper stage: vertical takeoff, aerodynamic descent, belly flop maneuvering, and propulsive landing. Each prototype flew a little higher, stayed in the air a little longer, and returned a little closer to the intended touchdown zone. Then came the big leaps, literally. With SN8, SpaceX took a bold step into the unknown. It was the first full-size Starship upper stage to attempt a 12.5-kilometer flight. SN8 soared through the sky with 3 Raptor engines roaring beneath it, transitioned to horizontal flight, and plummeted back down for a dramatic landing attempt. The result? A fiery explosion, but also an overwhelming success in terms of data and validation. The guidance systems worked. The control flaps functioned. And most importantly, the vehicle survived nearly every phase of flight except the very last few meters. That test set the tone for what followed. SN9, SN10, SN11, each with lessons of its own. Some landed, some didn't. But the pace of improvement was unmistakable. By the time SN15 took flight, SpaceX had achieved its first successful soft landing of a full-scale Starship upper stage. That single flight marked a turning point. It proved that the vehicle could complete its mission profile safely. It gave the engineers confidence to push toward orbital flights. And it made the idea of a fully reusable upper stage more than just a dream. Now in 2025, we're entering a new phase. The Starship upper stage isn't just flying high, it's preparing to fly fast, far, and often. And to do that, SpaceX has to continue evolving the backbone of this vehicle, the Raptor engine. The original Raptor, often called Raptor 1, was a marvel of engineering in its own right. It used a full-flow staged combustion cycle, something never before flown successfully on a reusable engine. This allowed it to burn methane and liquid oxygen with extreme efficiency and power. But as with all first-generation technology, there were growing pains. Manufacturing complexity, reliability issues, and thermal stress all had to be addressed. That's where Raptor 2 comes in. The engines used in this latest static fire test represent a massive upgrade over the originals. With fewer parts, simplified plumbing, and a more compact design, Raptor 2 is not only more reliable, it's also cheaper and faster to produce. This is crucial for a launch system that's meant to fly weekly or even daily. SpaceX has openly stated their goal is to eventually produce 1 Raptor engine per day. With Raptor 2, that goal is finally within reach. In fact, the static fire trials serve a dual purpose. They test the vehicle, of course, but they also test the engines themselves. Any anomalies that show up during a static fire can be traced back to manufacturing lines, helping engineers close the feedback loop. The engines that pass these trials go on to power real missions. The ones that don't provide critical insight into how the next generation of Raptors should be built. It's a real-time evolution, engine development that happens in the field, not just in a lab. The upper stage is also a laboratory in another sense. It's where SpaceX is testing future life support systems, cargo configurations, and even crude spaceflight procedures. While none of the current flights carry humans, that day is coming. NASA has already selected a variant of the Starship upper stage, called the Human Landing System, to land astronauts on the Moon. And that means every test today is one step closer to putting people on another world. And what sets Starship apart from other launch systems? Let's take a moment to compare. Traditional rockets, like NASA's Space Launch System or Blue Origin's New Glenn, rely heavily on expendable components. Most stages are used once and discarded. That's expensive, inefficient, and ultimately unsustainable for long-term space exploration. Starship, by contrast, is fully reusable, both the booster and the upper stage. That means the entire vehicle can be recovered, refueled, and flown again. It's the same logic that revolutionized air travel. And if SpaceX succeeds, it could drop the cost of access to space by orders of magnitude. Let's not forget the scale of this vehicle. The Starship upper stage alone is nearly 50 meters tall, taller than many full rockets flown by other countries. Combined with the Super Heavy booster, the full stack reaches nearly 120 meters, making it the tallest, most powerful rocket ever constructed. And it's not just tall, it's capable. The upper stage can carry over 100 metric tons of payload to low Earth orbit. That's enough to launch entire satellite constellations, lunar cargo modules, or even deep space probes in a single mission. And as wild as it sounds, this upper stage is also being designed for point-to-point Earth transportation. Imagine boarding a Starship in New York and landing in Shanghai less than an hour later. That's not just science fiction anymore. With reusable upper stages, that kind of high-speed global travel becomes possible, not decades from now but potentially within this generation. Of course, none of this works unless the vehicle performs flawlessly. That's why these test flights, static fires, and launch rehearsals are so critical. Each one gives SpaceX a better understanding of how the upper stage behaves in real-world conditions. From thermal stress during engine burns, to aerodynamic loads during descent, to software responses during abort scenarios, every variable must be accounted for. And the 9th test flight is expected to push those variables to the limit. As part of the upcoming mission, the upper stage will be tasked with not just separating from the booster, but achieving near-orbital velocity. That means speeds upwards of 25,000 kilometers per hour. At those velocities, re-entry becomes a brutal test of materials and control systems. The thermal protection tiles lining the Starship's windward side will have to withstand temperatures exceeding 1,600 degrees Celsius. The flaps will have to maintain stability in chaotic airflow. And the engines will need to reignite perfectly for landing burn. This is not an easy challenge, but it's one SpaceX is willing to face head-on. And even the landing attempt is part of a larger experiment. While earlier prototypes landed on solid ground, recent flights have explored the idea of ocean splashdowns. It's easier on the vehicle, reduces risk to infrastructure, and gives engineers a chance to assess recovery techniques in maritime environments. The long-term goal? Land a Starship on the Moon, or on Mars, or back at Starbase over and over again. But to get there, SpaceX must first master every element of descent, and every test flight brings them closer. What makes all of this so compelling isn't just the technology, it's the vision behind it. SpaceX isn't just building a rocket. They're building a new model of exploration. One where space is open to not just governments and billionaires, but to humanity as a whole. And at the heart of that model is the Starship upper stage, the workhorse that will carry us outward, one engine burn at a time. As we edge closer to launch day, all eyes are on the pad once again. The Super Heavy booster has completed its static fire. The upper stage has passed its own trials. Crews are stacking the two together, checking every connection, every clamp, every flight computer. It's an orchestra of preparation, and every instrument must be in perfect harmony. Because when that countdown clock hits 0, there's no room for doubt. So the next time you see those massive tanks venting, or hear the distant rumble of Raptors firing in the dark, remember, that's not just a rocket test. That's history in motion. That's the sound of humanity stepping off the edge of Earth, aiming for something far greater. And leading that charge, gleaming, towering, relentless, is the SpaceX Starship upper stage.